Hello, everyone. I am Randy Villahermosa. I am the general manager of what we call iLab. That's our innovation lab at the Aerospace Corporation. I can't make that up. That is, in fact, the name of our company, and we'll talk a little bit about what that is. But what I want to do with you guys is take you on a little bit of a crazy journey. It's going to cover 50 years of what has undoubtedly been one of the greatest human achievements, going to the moon. But it's also going to take us to the Amazon jungle, and it's going to bring us right back here to this room. So we're going to talk a little bit about why me, because I think that's a fair question, but then why is it a great time for space? When you look at sort of the evolution of trends in technology, in the 90s, it was all about biotech. And in the early 2000s, it was all about the dot-coms. I still want my shares back from eToys. So we had, then it was a transition to social media and the Internet of Things and AI and the whole reason why we're here today. But there's another evolution coming, and it's in space. And you saw a little bit of that yesterday, and then probably throughout the day today. So I just want to give you some context to how to think about space. A lot of people typically don't think about space, or at least not in a way that I hope you will find today is a little bit different, and also I hope that you will learn something new about why we think the robots are coming and what they will look like. Okay, so Aerospace Corporation, we're based out of Los Angeles as well as in the Washington, D.C. area. We started in the 1960s. If anyone has relied on GPS to get to a location, you can thank us, mostly. We were heavily involved in the original architecting of that system. And it started with a really simple question. In fact, a question that we largely take granted for today. Can I tell where I am anywhere in the world down to highly accurate lat-long position? I mean, that was an unheard of concept when we started working on this back in the 60s, and today it is what we know today as GPS. And so throughout the entire history of our company, we're a not-for-profit. Our main job is to advise the government on satellite systems, launch vehicles. Every single agency in the US government that launches, operates rockets or satellites, we are in one way or another work with them. And it gives us the advantage of perspective. We can see a really broad swath of what's happening in space. And part of my job with our innovation lab, and I know the innovation lab things are plentiful these days, but we really wanted to do something different with ours. And so I have one basic job in 5 parts. So first, I find all the mavericks at the company with the crazy ideas. I get them really comfortable to come out of the dark and to talk about them. And then I protect them so that we can grow them into what we think is going to be the next vision for space. And we're not, we have some experience in doing this. Back in 2000, how many people have heard of CubeSats? These tiny little, yeah, great, awesome. So I say that because like 5 years ago, I don't think I would have got the same response. Back in 2000, a couple of our engineers and scientists said, hey, we think we can take a satellite. And just to give you a sense of the scale, if I walk from this side of the podium to the other, that may be a quarter of the length of some of the largest satellites we built. And they said, hey, I can take that entire thing, something the size of a school bus, and we can shrink it down to something the size of a toaster. And now, we have iPhones, but we didn't have iPhones back in 2000, so you think, well, that's not really that big of a deal. But a lot of the technologies that go into making that big satellite tiny was only just starting to come on the horizon. So they did it. They launched their first CubeSat in early 2000. Everyone said, OK, that's great. But what can you do with it? So yeah, you can build these tiny CubeSats, and that's fantastic, but they'll never be a real business model for them. Fast forward to today, many of the companies that are here in the audience walking around giving presentations are companies based on those same small sats, CubeSats, that we pioneered back in the early 2000s. Today, we have 33 on orbit, and we just launched our most recent one about 6 months ago. OK, so why is it a great time for space? And I like to use the context of really 3 factors, if you will, that in my mind really drive what causes a technology or a space to go viral: tempo, ecosystem, and having a compelling problem. And let me give you my favorite example, Tesla. I actually don't have a Tesla. It's a very complicated love-hate relationship because I really want one. I have a really long commute. I live in Los Angeles, but I just can't bring myself to do it. So that's a whole other therapy session. But what I do, I'm a chemist, so I really love that combustion. But I know it's bad for the environment, so I don't use any plastic cups or spoons or forks. So tempo. So Tesla, they said, hey, we need to get on a tempo that starts with that sports car, moves to the Model S, then the X, then the 3, then the Y. They're constantly pushing a tempo to keep pushing the technology, pushing the market forward. Things have gotten a lot smaller and a lot smarter. That's why we're all here today, so I won't spend a lot of time talking about that, other than to say that much of space looks like 1960. Much of space technology today looks like 1960. That's a huge opportunity to take all the things that we do here on Earth and bring it up there. The only problem is that last thing. What is the compelling problem? Some people say, I want to go to space. I want to be an astronaut. I think that's possible. I think it could very well be that in the not too distant future, anyone can go to space. I think it's probably more likely you'll go to space and be able to get in line at Galaxy's Edge at Disneyland. Any of the Imagineers in the audience, I would really love a pass because my wife used to work for Disney. So what is the compelling problem? Why should we amass all this technology and put it into space? Certainly the venture capitalists have ideas about that because they are heavily active in this market, and that's only growing. So you saw, if you were here earlier, there was a previous chart that showed the growing number of satellites that are being launched. A lot of them are private, which is great, so the whole democratization of space. But part of my job is to ask really obnoxious questions like, okay, we're coming up on 50 years of Apollo. Apollo was an amazing achievement. I wasn't alive back then, but you can imagine that prior to Apollo, none of us really thought about what we could do in space, let alone put people up there. So it just completely opened the aperture of what we, not space people, but the entire globe, what is possible. And I would like to think that a lot of what we do today is traced back to that singular moment. But it's almost 50 years. And so what has happened in the 50 years in space, and is there something more we want to do? Well, I can tell you one thing that's happened. Debris. So it turns out, space is pretty big. It's really hard to get things into space. Gravity is not your friend. And we tend to leave things up in space. So there are things that get shed off the space station unintentionally. If you saw any of the Blue Origin or other rocket companies, a lot of times the ones that aren't reusable. By the way, as an aside, the whole reusable rocket thing is really amazing to me. Think of it this way. You take a bus to work, and then throw away the bus. That is what we do with rockets today before SpaceX and Blue Origin said reusable rockets are actually feasible. And by the way, that technology is known. That technology is 30 years old. The innovation really came in the business model that made that possible. But anyway, so there are these rockets that get launched and they don't come back to Earth. They're floating around in space. And it turns out that you can actually track several thousand pieces of debris, because debris in the sense that they literally don't do anything, in space. And we're cutting off the limit here, so you'll see the debris count go up. Things were really quaint back in the 50s, 60s, 70s. Sputnik was was obviously the first. And then you're going to see a spike sometime around 2007. You get extra credit if you know what caused that. The active objects are the ones that we care about. If you understand space, that big ring around the Earth is called the geobelt. That's the satellites that stay in the same position like DirecTV. So as the Earth is going around, those satellites stay in place. But then there's a big crowding of things around the Earth, what we call low Earth orbit. To be sure, there isn't really a risk today of, well, what do we worry about? We're worried about hitting debris. We're worried about astronauts hitting debris. We're worried about our satellites hitting debris. When two things hit in space, they cause more debris. There's actually a thing we worry about, this theory that says if enough things are in space and it gets crowded enough and they start to collide, you can have this cascade effect and just generate an enormous amount of debris. We think we're safe for now, but nonetheless, do we really want our legacy in space to be to repeat the things we do here on Earth? So that's the question. So maybe we should think about robots doing things that humans, frankly, can't do very well. It's actually a really, really hard problem to remove all the debris in space. And if you want to get a sense of why that is, put your hand up in the air and put it down when something actually flies into it. That's kind of what it's like trying to catch debris in space. There's just a lot of space up there. It takes a lot of fuel. They're not clumped together. So it's a really hard problem. Frankly, only robots could solve this problem. And it would certainly make me love robots a lot more if they could do this for us. And I think this is one of these things where you don't want to just remove some debris. If we're going to do this, let's figure out how to do it for all the debris that's up there. So that's where the robots come in. And I got to tell you, as a space person, I've been doing space now for 16 years. So right after elementary school, went right into space. And someone came to me one day, one of our Mavericks, and said, hey, I think we really should be looking at robots in space. I immediately thought, Cylons, so sorry if you're an original fan of Battlestar Galactica, but if you know the new series and you get a little choked up when the Cylon flying robot dies and tumbles off, that's what I was thinking. I'm like, there's no way we're going to do that. That's just all science fiction. But then we started to look at this a lot closer, and we're like, wait a second. Actually, Apollo 7 can be thought of as the first robot in space. The astronauts, as a way to practice to go into the moon, actually had to separate from their rocket, turn around, and come back. That's called a rendezvous and proximity operation. So you come apart and you come back together. That was repeated in 2007, but this time it was done with a robot arm as part of what was called the Orbital Express mission. And today we're all familiar with the arm on ISS that does a lot of the loading. So then I thought, okay, I could see how we could use robots in space. We have an arm, we can move stuff around. And they said, no, Randy, you got it all wrong. Because that little tiny dot, that's where we are today. We manually control robots in space. We joystick them. We give them manual commands, maybe a little bit of rule-based autonomy. But we are just so scratching the surface of what we could do. So today, we probably have all the technology we need to have actually robots be able to have satellites act like robots and actually interact together, maybe like in swarms. And the whole trick with satellites today is the smaller you can make them, the easier they are to get to orbit. But once they get small, there's a physics problem. You usually need pretty big apertures to do a lot of things you want to do from space. Take pictures, move cell phone signals around, broadcast TV. But if you can get satellites to act together cooperatively, then you can start to look like the bigger satellites and do a lot more capability. So imagine there's some distant future where we have a lot more digital control. Maybe the AI we think about today is really driving a lot of that. Again, there's a high-stake problem here that if we get this wrong, the satellites hit each other, we're back to that same debris problem. But I actually want to talk about the last edge. Part of my job is to do the things that you can't even begin to think about how you would do and invert that equation. So what I'm going to focus the rest of the time talking about is self-awareness and emergence. If you follow biology, if you follow physics, you've probably heard of things like phase changes or emergence. This is where a large collection, typically of small things, a large collection of objects can work cooperatively and not even realize they're doing it. But they're able to do things that you would be amazed by. So this is where we're going to go to the Amazon. I didn't lie at the top of my talk. These are army ants. And what you're going to see them do is a pretty amazing thing. They're going to form a bridge as this gap opens. And this is some really fantastic work done out of NGIT. And what you see happen is as the ants are crawling, and they go, oops, a little too far. So if they can't move any further, they really only have two simple rules. If you can't go any further, stop. OK? And when you stop, you're going to feel someone walk on top of you. Don't move. Now, there's an extra rule that says if you start getting bored, OK, move around, because maybe by that point all your friends left you behind. But you can actually see that happen. So all the ants on the bottom, They're starting to get bored. They said, hey, maybe I should come back up and see what's going on. Maybe I can help. The other ones who are walking on top are telling the ones underneath, hey, don't move, I'm walking on top of you. Just 2 rules. And they can build a bridge, and they do this all the time. So what does that look like for space? So we started to think about this, and we came up with this concept we call Hive. So scale is not really good in this picture, so imagine each one of these is about the size of a Kleenex. So we're back to those CubeSats. And really, these CubeSats are the hero of the story because they're the reason why we think this is going to be possible. So imagine rather than having 1 satellite, we had hundreds, maybe even 1,000 satellites all working together. They're working as a swarm. They're working like those ant colonies. We give them really simple rules because we don't think we're clever enough to get all the things right the first time. And we also want them to be able to adapt. We want to tell them, I give you a very simple command. I want you to go find that piece of debris and take it out of space. And they will figure out how to do that. They will collectively figure out where they are in their swarm. Some of them will have the job of generating power. Others will use their small processing capabilities, but combine it with others in a cloud and form their own AI net and be able to do that very hard processing as a collective. You notice that each one of these looks a little bit different. Each one is given a different sort of tool or mission. One can take pictures. One's dedicated to generating power. Another one works in RF. That in and of itself, though, is not particularly new. And also, it does have this problem of now you just have a lot more objects in space. But what if they could connect to each other? So we said, well, maybe they should self-assemble in space and form these connected collectives, but that they can reconfigure. So in this little cartoon, what we're showing is one of them gets damaged. He says, all right, see ya. It's been great. He takes off, heads back to Earth, dies a fiery death, but the others are there able to recover and replace and to be able to do that. All that technology is known today. The question is whether we can put these pieces together to be able to come up with something like this. And so now you can imagine these swarms of hives, these swarms of satellites roaming space, looking for the debris that we left behind, tracking them, cataloging them, and then eventually taking them back down to Earth. I would love that robot. That robot is doing me a solid, and I would definitely appreciate it being there. And the nice thing about it is that we're also working on how you make these all standard and modular so that anyone can build these. Where we talk about democratizing space, there's a lot of versions of that. I may not be able to get myself into space, but what if I can get my know-how? I can have the ability to command these in space. I can operate in space. Not very different, frankly, from cyberspace. For the most part, most of us are probably not going to get to space, and cyberspace is the same deal. And look what we've been able to do there. So the question is, how do we do that? So that brings us to sort of the last big idea here, which is that every big idea really comes about because of a lot of small bites. Just like 2000, when people said, hey, you can build these small satellites, but what will they really do? Now we're saying, hey, these satellites can act like robots, but it's not the robots we're used to thinking of. It's not the robots with the arms. It's not the robots that have locomotion that can do things that humans do. These are robots that only can do things that robots can do. They have the autonomy. They can take advantage of space. So that's the nice thing about space. You get it's good and bad. You get 6 degrees of freedom. So it's both challenging, but also can be quite liberating. So that's what led us to this idea of coming back to Tesla. And frankly, when we tend to think, so I was thinking about this the other day. We have this, everyone knows the phrase, a moonshot, right? It comes from going to the moon. We're going to head back to the moon in 2024, so, hoorah. That's amazing, and we're definitely involved in that. But I also think it did a little bit of a disservice to us, because whenever we talk about moonshots, we think we're just going to go for it. You just take, he said it, one giant leap for man. But in reality, did anyone ever stop to think, why was it Apollo 11 and not Apollo 1? It wasn't because there was 10 failures. They had to do 10 steps leading up to that final momentous moment. They had to practice around Earth. They had to fly. Can you imagine being the person who got to fly around the moon and not land? Oh. So they had to build up to it. So what would that look like for robots? Well, today we can do things solo. We know how to launch satellites. We can put them in orbit. We can even do things tandem. So there are companies that are getting really good at being able to dock with each other and be able to use robot-type attachments, robot arms, appendages, to be able to do things like refueling, as well as repair. And in fact, this is, again, not particularly new, because if you remember when Hubble had the corrective vision problem when it first launched, it had a little bit of blurry vision. They had to replace they had to put in some new optics to fix it. Fast forward a few more years, they said, hey, we want to upgrade that again. Should we do it robotically? And so these aren't really necessarily new ideas, but the question is, where do we go from there? So then I just talked about self-assembling swarms. That's sort of the hive concept where they're not attached. So you have individual satellites flying around, and they're able to do things that the bigger guys can do today. There's a version of robotic servicing in the future. So wouldn't you like to be on the New Glenn or the New Shepard? You're on a trip to the moon, and then all of a sudden you start to see a little gas leak. That would never happen. Jeff, if you're here, that would never happen. But if you happen to see a little bit of a problem, wouldn't it be great if a robot satellite could come and do the repair while you're on the way to the moon and not have to worry about it? Well, that's really complicated. Because again, you have that 6 degrees of freedom. We have to worry about not running into each other. Things are moving really fast in space. It takes a low Earth orbit only 90 minutes to go all around the Earth. But then if you could do that, then that leaves you to this last thing, this emergence, where you have the satellite self-assembling, and you're able to give them really basic commands, but able to do lots of missions. I talked about the debris one. One of the other ones that has me really interested right now, I'm really excited. What if we sent a swarm of Hive satellites like a comet, like Halley's Comet? We can sell the naming rights, but it's just going to go out and come back in 50 years. And Voyager's gone really far, so that really isn't the point. But imagine as it's going, it's dropping off little nodes and forming literally a space internet as it goes. I mean, talk about expanding the reach of mankind and being able to actually take live images of different objects out there. And you say, 50 years, that's like a really long time. Well, it's been 50 years since Apollo. So that's the reason why I start to think, maybe there is something more we can do. And so, I bring it back to everyone here. You're all technologists. You do machine learning, you do AI, you do space. This is where the power is. So I like to think, I'm a chemist, so I like to think about the fire triangle. Anybody know what the fire triangle is? Sorry. Yeah, OK. You need fuel, oxygen, and a spark. Well, the spark is easy. The Elon Musk and the Jeff Bezos of the world have really reignited our imagination about what we can do in space and why we should be there. The fuel is you guys. You can do anything you want. You could be working in the consumer space. You could be working in the product space. You could be working in entertainment. But maybe you could also be working on these problems in space. And that's where the oxygen part comes in. What will it take for us to keep breathing this idea that space is the next frontier? And I think it's thinking of these missions, thinking of these applications that really extend what it means to be a human. We all believe in the power of space to make life better here on Earth. I think it's only a matter of time before we start to see more and more great ideas come about what that might look like. So I guess I would leave you with this thought. As you're thinking about what your next challenge is going to be, what next company you're going to work at, if you're like me, you're a good scientist or an engineer, you're probably looking down most of the time. Stop and look up. If you're looking for your next Everest, it may actually be in space. Space is really hard, but we need all of you to make it just a little bit easier. I want to thank you for your time. Thank you for hanging out with me today, and I hope you enjoy the rest of the conference.